Hi, welcome to my video on finding the X and Y-intercept, domain, range, and asymptote of exponential function. State the domain, range, asymptote of each. Notice all the graphs we're looking at the domain of the exponential function, which is y equals ab to the x. And that means that if we look at this one right here is a growth curve because it's going up to the right. And the domain of all of these are always x belongs to the real numbers. Any value of x can go in the exponent as long as they're a real number. So x belongs to the real numbers is the domain of each one of these. X belongs to the real. So do that first. Now, let's look at the asymptotes. The asymptote is a line that the graph goes towards but never touches. The asymptote here is horizontal and is y equals 0. The asymptote is always a horizontal line, and here is y equals 1. The asymptote here is y equals -2. The asymptote here, this one, is y equals -1. And the asymptote here is y equals 2. Again, the domain is always x is always the values belonging to the real numbers. The asymptote is always a horizontal line and is y equals. And the range is in terms of the asymptote. So the range is y and 0. But this graph is going upward, so all the values of y are greater than 0. And y is 1, and again the y values here are above the asymptote, so y is greater than 1. And the asymptote here is -2, and all the y values are less than -2 because it's going down. The curve is going down. And y equals -1 is the asymptote, so the range is in terms of the -1. And all y values are going down, so it's less than -1. And the asymptote here is 2, and the y values are above that, so it's greater than. So just some examples of picking out domain, range, and asymptote. Now let's look at some equations and pick out x-intercept, domain, range, and asymptote of these equations. Here we go. So we have an equation y equals 2 bracket 3 raised to the x plus 2 minus 54. So we want to get an x-intercept. So we want the x-intercept. So to get the x-intercept, we let y equal 0. So we got 0 equals 2 to 3 x plus 2 minus 54. Now let's move the 2, this expression, to the left side and make it negative. I want to solve for x, so let's move the x to the left side. Now we'll divide by 2 because we want to isolate the base. So 3 to the x plus 2 equals 27. And the base is 3, so 27 is 3 cubed. Since the bases are equal, the exponents are equal. So x equals 3 minus 2, x is 1. So the x-intercept, when x is 1, y is 0. That's the x-intercept. X-intercept is 1. And we want to find a y-intercept, so we'll let x equal 0 in the equation. So y equals 2, 3, 0 plus 2 minus 54. And we work out the exponent, which is 2. Now we'll work out this expression because it has a power. So 3 squared is 9 times 2 is 18. So y is -36. So when x is 0, y is -36. Now we want to look at the domain. And the domain, this is an exponential. Notice y equals 3 to the x is the basic curve here. The base is 3. It's a growth curve. But the domain is always x belongs to the real numbers. And the range is in terms of the asymptote. So let's write down the asymptote. The asymptote, when it's written in this form, the asymptote is always the value of k. So the k value, the asymptote is y equals negative 54. It's always the number on the end when it's solved for y. And we have an exponential. And the range is in terms of the asymptote, which is y equals negative 54. And notice this is a plus, so the y values are going up, so the range is y is greater than a negative 54. Okay, and let's look at another one. Again, find the x, y-intercept, domain, and range of an asymptote of this equation. Make that an e there. So we want to get the x-intercept, so we let y equal 0. So 0 equals negative 3, 1/2. And that's written down. Move the 3 over, make it positive. So we get 3, 1/2. So I'm just rewriting the equation with this expression, move to the left side, making it positive. Now we divide each side by 3, and we get 1/2, 3 to the x minus 1, and the 3's cancel, and that gives us a 64. Now the base is a half, but we'd like to write it in terms of what's the base is going to be a 2, so 1/2 is 2 to the negative 1. Keep the same base. And 64 is 2. 64 is 8 times 8. 8 is 2 cubed. 2 cubed. So that's 2 to the 6. So we have 2. This is the power of a power, so we multiply negative 3 times x minus 1 equals 2 to the 6. Now we have both bases are 2's, so negative 3x minus 1 equals 6. So negative 3 plus 3, negative 3x plus 3 equals 6. Negative 3x equals 6 minus 3. Negative 3x equals 3. Divide by negative 3. And x equals negative 1. So when x is negative 1, y is 0. That's the x-intercept. And we want the y-intercept, which we make x equals 0 in the equation. So y equals negative 3, 1/2, 3 times x minus 1, add on 192. And we got to make x equals 0, so put 0 in the place of x to right there. So y equals negative 3, 1/2, and that's 0 minus 1 is negative 1 times 3, so that's a negative 3. And we simplify this. I just want to do this part first, which has the power. So the negative flips the fraction to a 2, so 2 cubed is 8. So I wanted to do that first, just to make sure you can see. Remember, a half raised to the negative 3 is 2 cubed. So when you remove the negative, you flip the fraction to its reciprocal of 2, and then you cube it. So that gives me negative 24 plus 192. So y is 168 when you add them up. So that when x is 0, the y-intercept, cut the y-axis at 168. And the domain, this is an exponential curve, y equals ab to the x. So the domain is always the real numbers. And the range and the asymptote, and I'd like to look at the asymptote first. The asymptote is always the number on the end when you solve it for y exponential. So the asymptote is y equals 192. And the range is in terms of the asymptote. And since this is negative in terms of the y, this is negative here, that means the graph is opening downward. So the range is less than 192. The y values in this equation or in the graph is always less than 192. And one more to do. It says this equation is negative 4, 2 is the base, x plus 1 minus 20. And again, y equals 2 to the x. 2 is the growth curve. And we want to find the x-intercept. So to get the x-intercept, we let y equals 0. So we put 0 in the place of y and solve this equation. Move the 4 over and make it positive. Now we divide by 4 to isolate the base. Notice now we have the base 2, x plus 1 equals negative 5. But no matter what value of x I sub into this equation, this value will never be a negative 5. Because any value of x that you sub in here, this will be positive, greater than 0. So that means that your, because the values of y can never be, you can never give a negative. So that means there's no x-intercept. This graph does not cut the x-intercept. And if you look at the graph of it just for a second, notice that the asymptote is y equals negative 20. So let's pretend we got negative 20 right here. So the asymptote is right here. Remember, this is the x-axis, this is the y-axis. So if the asymptote is y equals negative 20, this graph is negative, that means the graph is going downward. So that means the graph is going to go like this. Because if this was a growth curve, because it's a 2, so y equals 2 to the x would be a graph doing this. So when this is negative, it's reflected in the x-axis. So there it is there. And so that's why it has no x-intercept. No x-intercept. Just a review of solving equations, looking at different aspects of the exponential function. If you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.